Welcome to our lesson about using constraints in your assembly. Constraints let you position components accurately in relation to other components. In other words, constraints remove the degree of freedom between selected components. The Constraint tool is located on the Position panel of the Assemble tab. Let's begin by activating it. Left-click on the Constraint tool. The Place Constraint dialog window opens. The first type of mate we're going to look at is mate. That's the icon on the far left here. Let's left-click in the graphic area to select the faces we want to mate. The Place Constraint shows us two solutions, mate and flush. The mate option positions the components face to face. The flush option positions the components with the selected faces in the same direction. Notice that the first face is shown in red line, and the second face is green. You can see the corresponding colors, red and green, in the first and second selections up here in the Place Constraint window. If you've made a mistake, just click the selection buttons and reselect your faces. I'm going to use the mate option. Now let's click Apply and then cancel out of the Place Constraint dialog window. Now Cube 1 can move only along this face. Let's activate the Constraint tool again. We'll stick with the mate type of constraint for now. And let's select this face and this face. This time I'll use the flush solution. Let's apply and cancel out of the tool. Now as you see, our cube moves only in the Z direction on top of the plane that goes through this face. Let's activate the Constraint tool again and place another constraint. Mate, and I'll select this face and this face. In this case, we have only the flush option available. Let's see what happens if I select mate. Let's apply, and the assembly cannot be solved. We get an error message. I can edit the constraint, I can cancel out, I can accept the constraint, and I can diagnose the constraint. Let's select Edit the constraint. We're going to apply a flush solution instead. Apply and cancel out of the tool. And Inventor is able to solve this mate. Now if I try to move the cube, I have a symbol next to my mouse indicating that this component can't be moved. It's got 0 degrees of freedom. Now let's take a look at how we can edit our mates. In our tree, I've got one mate and two flush mates. When I mouse over the mates, they're highlighted in the graphic area. This makes it easier to understand their location. Let's double-click on Flush 2, and let's enter an offset distance. Let's say 0.25, quarter of an inch, and click OK. Now let's right-click on Flush 2 and select Edit. Now we can reselect the mates. I'll select this face. Let's enter an offset distance of 0.5, half an inch. And I'll select a second face and click OK. Now we've got a half-inch offset in parentheses next to Flush 2. Let's right-click again and select Modify. Let's change the offset distance, for example, 0.25, quarter of an inch, OK. Now let's activate the Constraint tool again. I still have the mate type selected. I'm going to mate this cylindrical face and this cylindrical face here. Let's apply and cancel out of the tool. Now the fastener moves along the axis of the hole. We're also able to rotate our fastener. Let's activate the Constraint tool again. Select this face and this face. Let's apply and cancel out. Once again, let's double-click on Mate 2, and let's adjust the offset distance, let's say to 0.25 inches, accept. Now we've got our fastener axis offset 1/4 inch from the hole axis. Let's double-click on Mate 2, enter 0 and accept. Now let's right-click and delete. Delete again. Activate the Constraint tool. This time I'll use the Insert method. I'll select this edge and this edge. Notice that we're able to make selections right through the solid. Just left-click to make the selection. And let's apply and cancel out. Now the fastener still rotates, as you see. I'm still able to apply some more constraints then. Let's use an angular constraint. I'll select this edge here and this edge. And now let's enter an angle value. Let's leave it at 0 degrees. Apply and cancel. Now the fastener is fully constrained. If I try to move it, I see the symbol next to my cursor that indicates it's got 0 degrees of freedom. I'm not able to move it. However, in this case, the angular constraint isn't necessary. Even without it, while we're able to rotate the fastener, it's still adequately constrained. If we need to, we can make some adjustments to the solution type. Let's right-click and select Edit. And let's choose the aligned solution. Let's cancel out of the tool. And let's apply a few more constraints. Activate the Constraint tool. Mate type. Let's select this face and this face. And click Apply. Now let's take a look at the tangent type of constraint. In order to use the tangent constraint, at least one of the faces needs to have curvature. Let's select this cylindrical face and this face. Here we've got two solutions, inside and outside. We can also use an offset distance, for example, of 1/4 inch, 0.25. And let's apply and cancel. Let's test our mate. Looks good. Now cylinder 1 moves around the cylindrical feature of the base. Let's activate the Constraint tool again. And let's select this edge and the y-axis. Let's apply and cancel out of the tool. Now the cube moves along the y-axis. One more constraint. Lastly, I'd like to apply an angular constraint. I'm going to select the x-axis. The x-axis becomes highlighted in the graphic area. Let's enter an angle value of 45 degrees. Select this edge in the graphic area. And let's apply and cancel out of the tool. And let's test our mate. Now the cube can move only along with the y-axis, but it can't rotate around the y-axis. And this concludes our lesson about constraining your assembly.